我还看了头的角度，为什么？我也是，我就看没有。你们坐前面。这是挺亮镜。
太高了。
坐前面容易被写。我要把你的我后来我很好看。这样的话。Let's wait a few more minutes. In the meanwhile, you can look at the Moodle first. Later, I'll brief you on Moodle. 因为我看到你已经看了啊，我说我看到你已经 send 了。OK， 好像有一个小错误，可是觉得 topology 更好。我弄好第一个。哦，你再改一下给我，你再改一下那天我跟你讲的，然后你给我一首。你会有一个词吗？对，我改一下给我。好，已经改好了。下课我抄晚一点而已。啊？我说第二课我稍晚一点也会给你吧。OK。那个我说你这边有个小错误，哪一个？没有，不在这里，什么东西？等一下再说。有一个 AI 写成 XI 了。OK。等一下。可能等一下我会发觉到，可能我不。Anyone know if Ivan is back yet? Ivan. 啊，不确定。你们早上没有上课啊？Okay. So if you are taking this course, right, maybe you can sit closer a bit. Later we'll do some interaction. If can sit closer a bit. Yeah. If you are taking this course, right, you can sit closer a bit. Do you need to turn off the light? Can see. Okay, so you cannot see Lydia. You want to turn off the light or try first? Let me brief first. Turn off already. Okay.
because I turn it off, not good for my eyes, but never mind. Yeah, never mind. Okay, so before we start, right, I want to make some introduction first. I want to make some introduction. I think for most of you, you know me already, and I think masters don't know me yet. So I'm Seng, so you can call me Seng. Just call me Seng. So let's talk about introduction for me first. Okay. So and then I'll talk about this course. So I graduated from Australia, so Australian National University, where I go study pure maths ever since my degree, and then I finished PhD there as well. My area is in representation theory, but representation theory uses some language from algebraic geometry. So that's the motivation I started this course. But even that, our course, if you notice that it's called classical algebraic geometry. Why is it classical? Because most objects that we deal here are curves, okay, surfaces, lower dimensional, or we just deal with polynomials, okay. But actually, advanced until this day on algebraic geometry, there are new language that put up. If you look at the Moodle that I put on, let's see. I put several reference here. My course has one what's cursor in English? Characteristic. So I put a lot of reference here. I like to do cross-reference. I don't believe one people only. Okay, so make sure all of you say the same, then I will believe. Okay, so there are a lot of reference here. Maybe I'll update it based on the chapter we go into. I will put into the weeks. Okay, and you can read them. But the main reference is this. Even though I said it's a main reference, I won't fully follow it. Later you'll know why. Other than that, before we start, right? Unfortunately, the first week are all holidays, so we don't have class. So you cannot experience it, and then whether you want to drop or add or not. Okay, so this is a scam. Okay, so this is a scam. But anyway, you are here already. You cannot leave anymore. Yeah, so there's some homework for you, right? For week 1, I put a lot of things here. In particular, this one, Recoster at Simmels by this Grothendieck. Okay, in English, it's harvest and sowing. Okay, so this is the idea Grothendieck have on algebraic geometry. So who is Grothendieck here? So Grothendieck is a guy that modernized algebraic geometry course. Okay, so if we did good in this subject here, maybe in future we'll open up another course on modern algebraic geometry. Okay, in near future. Okay, yeah, near future. So yeah, so if you have free time, right, you can read it as a story. Actually, this is not mathematical. Actually, this document here is some reflection. Okay, reflection on doing maths, and reflection on how he came out with the idea. Okay, revolutionizing this algebraic geometry. And a lot of things we did today, very advanced algebra, like category theory, is actually based on this idea, on Sheaf's scheme, if you know. Category theory, yeah, Grothendieck. I guess this is the nearest scope we have compared to Euler, Gauss. Okay, I think even compared to Hilbert, I guess. Yeah, we're gonna have a revolutionization on physics using this maths. Because the last revolutionization is on relativity, right? So those are the maths done by Riemann. Okay, those are differential geometry. And then we're going to use, hopefully, this algebraic geometry will be something useful to describe quantum physics. Okay, because quantum physics is discrete. So the algebra is pretty important. And I put some extra book here. Later I'll explain it. Okay. Yeah, so I introduced about this course, introduced about myself. And then I think we need to update everyone. Maths is very hard. I guess all of you know here. But I think in this class, right, all of you are elite. So why you choose this course? Because you dare to pick up the difficulties. Okay, so I think I won't too worried about you self-studying. Okay, yeah, you are not like usual. We call them magua. English is what? Muggles. Muggles. Don't know magic of muggles. Okay, so you are not muggles anymore. So we should try and put effort to learn together. Okay. So these are the 4 principles that I uphold in my class. One is freedom, one is make sense, the other one is rigor, last one is clarity. So in case you feel that this principle is not satisfied, you should talk to me. Okay, we should do based on this. This is our contribution. Okay, so if you found that some proof is not clear or doesn't make sense, not rigorous, you can ask me to fill it. Okay, and also for my assignment, right? So okay, let's talk about assignment then. So let's go to our setup. So this course, by the way, is an advanced undergrad course. It's an advanced undergrad course such that we design it actually as same as the master course requirement. Okay, so there's no midterm here. So we won't put too much focus on exams. Okay, we still have exams, by the way, we have a final exam. So the split out is like this. So 40% of assignment, report or presentation together, 30%, final 30%. Okay. We will see how whether we want to make our final into open book or what. See what's the progress. And then assignments, we only put 4 assignments for you. Why 4? Because those who know me, I like to put a lot of assignment. Because I need to put some weight on report actually. Yeah, we're gonna have a very interesting group report this time. Okay, so there's 4 assignments here. 4 assignments maybe look like this. So this is a tentative plane. We'll see how it goes since we already don't have big one. So we'll see how it goes. But at least I think my goal is to give you assignment 2 weeks before the due date. Give you about 2 weekends to do it. Okay. At least. Okay. So there are 4 assignments here. Right. So how about go to the main point first? Go to a project. Okay. So this project will be a group project. Okay. Group and individual. Okay. Group and individual. So what you do is you need to form a research group of 5 people. Okay. I already count already. I somehow get your demography already. I know which batch you come from. So it works. Okay. So later I will explain more to you. So this group, right, I put some restriction here. Okay, so one group only can have 1 master. Okay, and then these master students need to find 12209. Find an ID with 2209. Okay, and then find one either from 2302 or 2304. Okay, only one, and then one from this set. This set of 4 people. Okay, you cannot have more than 2 people from this set. Okay, then others you can basically you have no choice to fill the 5th spot. But if you don't get your group yet, we will finalize it by this week. Okay, so hopefully tomorrow, all the master students should give me a list of this. Okay, so what should these people do? Okay, let's see what should these people do here. I put some word lot here. So let's not look at the negative one first. Let's not look at the negative one first. Let's start with 1 actually. Our natural number should start with 1, right? So let's do 1 first. So 1 is this master student. So this single guy here, what you need to do is you need to form a research group. So there are 4 of you here. Okay, so you need to form a research group. And then you give me a list. Okay, by tomorrow, end of the class tomorrow. Okay, otherwise you will be randomly mixed. And then you need to write a progress report, okay, for 12 weeks of meeting. So what's the meeting here? Let me write it down for you. So once you form a meeting, right, I give you a timeline here. So this is current week, right? Okay, current week. So at least you need to start a meeting by this week or next week. Okay, and then by week 4, the 4 groups should meet with me to decide topics. Okay, and then you do your own meeting, maybe for 2 weeks, and then meet me again. And then you meet yourself, and then meet me again, meet yourself, and then meet me again, and then meet yourself. Okay, and then here will be like 12 weeks here. Okay, and then you will present on the 15 weeks. Okay, does it make sense? Okay, so I think you should meet with me like 4 times at least. Okay, yeah. So the idea is you discuss. Okay, you decide, you ask me correct or not, wrong, go back, do, correct it, wrong, correct it, wrong, correct it, wrong, correct it until you present. Okay, easier, can understand? Okay. So yeah, so this postgrad I require to write a progress report here. Later this progress report will be useful. I'll tell you how is it useful. And then all the other guys, what they do, like what these undergrad do. I also split them into doing progress report also, but they just need to do for 3 weeks. Okay, they just need to do for 3 weeks. So why I formed this because since you are in master, right? I guess your future is you want to experience more about research life, right? So this is research life actually. You need to write progress report for your grant, for your project. So you need to write it. Okay. And then why I asked this undergrad to do another progress report, because I want to see your meeting from different viewpoint. Okay, because in the end there's one evaluation here. So let's see what's the evaluation here. So I split this 25 marks, right, for your project into 4 components here. First component here is teamwork. Okay, so there's evaluation for teamwork here. So in the end of this project, I'll ask you to do evaluation on each group member. Okay, and then we'll decide the mark from there. Okay, and then any discrepancy, I can check back your progress report, see what happens during the meeting. Okay, so make sure you write down. Later, I'll put some details on what you need to report in your progress report. But this is the idea. Okay, okay, yeah. Okay, so there's a bonus mark here. Okay, you can earn full marks now. You can get the full teamwork mark if there are role buff and group buff here. What does this mean? If the leader really doing the job, okay, if the group member are really doing the job, there's a role buff. And then if a group buff, if the whole group present very well, there's a group buff. Okay, so there will be extra mark. There's some extra buff here. Okay, so I put some tips here. Okay, so presentation will come later, but the current plan is for you to do a quick lecture here. So actually, the design of this course, right? At first, I want to do it like a reading course. Have you heard of reading course before? I think this is not common in SMUM here, but it's very common in my uni. So when we get into a 4th year, 3rd year, there will be a reading course on a hard topic. For example, commutative algebra, for example, vector bundle and K-theory, something like that. So what do we do in the reading course was the lecturer will assign us some chapter or some section to read, and then we present. So this is part of the assessment also. And then the lecturer will give assignments as well. Okay, but there's no exam. Yeah, but there's no exam. But unfortunately, we need to have exam. I also don't want exam, but we have to have exam because due to some MQA requirement here. So instead of doing the whole course to be a reading course, right, we do like only the special topic for reading course. So I ask you to read something very advanced and then prepare for whole semester and you present. And then the first big part of the lecture will be me presenting like that. Okay, does it make sense? Okay, understand? Okay, okay. Yeah. So how about Yeah, what should I say here? Okay, so so what's my education philosophy here? Let me tell you my education philosophy here first. So I'm a Chinese guy, that's why I was in Mandarin here. So this is my Chinese education philosophy here. So in Chinese it says 十年树木，百年树人. So English says that you need 10 years to raise a tree, but you need 1,000 years to raise a man. Right? So meaning, if you want to educate people well, you need a lot of effort. Okay, you need a lot of effort here. So let me use the tree analogy to describe you how I design the course. Okay, how I designed this course here. So let me use the tree analogy to talk to you. So first, we will have a big tree here. So this big tree here comes from where? Actually, this is coming from lecture notes. Okay, I'll tell you what's important component in my class here. So this tree must be raised by this lecture notes here. So all of us have to preserve this lecture notes well. Okay, so if you find any mistake or anything, you should let me know. Incomplete, you should let me know. I will fill it in. Okay, everything tested will be from this lecture notes here. So out of this lecture notes, what you get? You get tutorial question. Okay, so for example, once I finish this week lecture, right, I'll give you a tutorial sheet to do. Something that I want to check on you that you know, or something I want you to know outside this lecture. That I have no time to go in deep. I want you to spend time doing that. Okay, like this is tutorial. And then from tutorial, I will have assignments. Okay, so maybe I'll give harder question based on what you know. Okay, what we learned from tutorial, or we can directly ask from lecture note also can. Okay, okay, and then only then our test will grow from here. Okay, our test will grow from here. Okay, also can grow from lecture note also. Okay, our test will go from here. Does it make sense? Okay, now. Okay, so in this class, right? I'm not sure I have enough time to prepare answer or not. Because this class actually is very brand new. No one taught this here yet. And even you go to outside a very advanced uni, they also seldom offer this course. Even in my own university, right, they don't offer this course every year. Okay, so so you need to bear with me. Maybe I don't have answer sometimes. Okay, so you need to find yourself. But you are welcome to discuss with me. Okay, yeah. Most importantly, you can discuss with me. I'll tell you the office hour later. Okay, so so this tree is on the soil, right? So this is a soil of what? These are a bunch of textbooks, and do a lot of readings. Only can grow this tree out. Okay, and then where's your project? Your project should grow from here. Okay, you should grow from here. So this is your project. Okay. Okay. Can I understand? Okay, clear, very clear. Okay, and then since you need to do group project, right? I will ask you to introduce yourself later on, but I want to tell you the demographic here first. Okay, basically this class, other than master, master are unknown for me actually. So these master are unknown tree for me. Okay, so you guys are individual guys. Okay, I don't know much. But I know about there's a 3 batch of students here actually. Maybe let the master know a bit. So there are 2209 here. There are 2302 and 2304. Usually these two are mixed together because 02 is a short set. And then there's another big group is 2309 actually. Okay, so I have approached these students before. They know me very well. That's why they picked this course. Let's start with 2209. Okay, so this 2209s have a very, how to say, comprehensive understanding. Okay, understand of me. Okay, why I say so? I have taught them actually multivariate calculus, which is calculus 2. And then they see my algebra also, abstract algebra. And they also see my topology before. Okay, so they are the fourth time looking at me already. Okay, so this is geometry now, algebraic geometry. Okay, so moreover, actually all the 2209 here are my FYP. Okay, so they know my pattern very well. So maybe master can know me through them. Okay, maybe, who knows? And then 2302 and 2304, they also know me starting from multivariate calculus. And actually, I go further with them in analysis actually. Instead of teaching them abstract algebra, we do analysis here. Okay, so this group of people, I have trained them very rigorous maths foundation, but not really much on the ideas and abstract ideas. But anyways, different training. And then they are looking at me in topology this semester and algebraic geometry. Okay, so actually these two parts are new. Okay, because due to their semester problem, they cannot do topology early. So they're going to do it this semester. How about 2309? 2309 actually a bit special here. They only took one of my course before, which is abstract algebra. Okay, I haven't touched them for first year. Okay, so but this group of people are very very enthusiastic, very enthusiastic. They even helped me to finish my lecture notes on abstract algebra. If you can look at it, I also put it here because the language of this course is based on abstract algebra 1. Okay, on group and so if you look at this one. So if you want to recall any language here, right? So please feel free to go to this lecture note. And then there are exercises for you to try as well. Alright, make sure you know some of the basics. You don't need to know all of them, but make sure you can recall them here. Okay. Yeah. So on the just now research group, right? Research topic. So if you want to think of it as these lecture notes, right? Deciding a special topic is like you decide some topic like groups, and then you split this section into your members. Right? You split into members. Or I will tell you what kind of topic you can pick, right? Okay, let's see what topic you can pick here. So there are a lot of interesting topics you can pick here actually. So I've listed a few. So first is Hilbert schema, Hilbert function, Hilbert polynomial. I can do all these together. And Grassmann and Schubert varieties. Okay, actually you can use linear algebra to learn some varieties. Or some linear algebra actually is about varieties. And then parameter spaces and moduli spaces. So moduli spaces is actually a very hot research topic. Okay, nowadays. And then flat varieties, detrimental varieties, and then Fano variety, toric variety, K3 surfaces are very famous in mathematical physics. You can do quotient varieties. Okay, if you learn about quotient group and so on, what is quotient variety, then projective quotient. We'll do projective variety in class, and then this is a quotient that's projective. Yeah. Or you can do elliptic curve and modular forms, and this will be very related to algebraic number theory here. Or you can do stable vector bundles on curves. This form a category. Moduli functor, the Verlinde formula. Mackay correspondence is a very old correspondence, and there are various understanding about this correspondence here. Actually, this Mackay correspondence here relate to the Platonic solid. Do you know Platonic solid? You want to know? Don't know. Platonic solid. Don't know. Okay, try and look it up. Perverse sheaves. Functorial algebraic geometry. This is the modern algebraic geometry I'm talking about. So the functoriality in algebraic geometry. CIT, classical invariant theory. So this has to do with singularity theorem. And derived algebraic geometry is really advanced. So if you have a very much basic, I can encourage you to do this derived algebraic geometry. And minimal model program actually is a very hot topic in the algebraic geometry field, but I'm not in that field, so I'm not doing it. But it's a good idea to look into. What is it? Okay, basically it's trying to classify some varieties, and then using a minimal model, you find a minimal one, okay, to represent that group. Gaga theorem. Okay, Gaga theorem is a very interesting theorem here. So basically, it's every complex analytic manifold you can describe using algebraic manifold. Algebraic varieties, not manifold anymore. So, okay, or if you're interested, you can look into this Grothendieck. Grothendieck left some writings. They call it SGA, FGA, EGA. All these you can look into it. Yeah. So for what you do is you form a group, look into these subject. So there are few choices. Either you have some idea and then you look for people with the like ideas, or you get the like people first and then you guys decide topics. Okay, so another reason why I met you guys to do group project is this is also by my experience before. Actually, when I do PhD, I have a friend doing PhD with me. So actually, I'm not alone doing a PhD here. Usually doing PhD is alone. Okay, you do on your subject, you follow what your supervisor asks you to do. But I'm different. How different am I? My friend is also from Malaysia also. From Malaysia. Yeah, so actually we have a common language and then we know each other quite well. Although we didn't speak much during undergrad, we know what we want, we know what each other want, and then we can communicate. Actually, at the first time, right, we very different. How to say very different? No, for example, when you solve one question, right, maybe there are two ways. We will definitely pick different ways. Not sure why. But it's very weird one. Yeah. But in the end, we can put together and then we come up with some papers. Yeah. And then these papers are actually part of my thesis also. So I think why I can graduate, part of it is my friend's contribution also actually. Yeah. So I think in when we study these hard topics, right, you need to get some peers to study together. Actually, in the current mathematical papers, right, you rarely see one person author. Rarely see. You rarely see one person author. Usually, you see multiple contribution. And in mathematics, right, this is a very different field. In particular, for pure maths, there's no ranking for order. Okay, there's no ranking for order. It's not like the applied side. They have order, first order, second order, corresponding order, something like that. Okay, in maths, we don't have. We just arrange by alphabet. So why is it so? Because maths has already advanced to a stage that we need knowledge from different fields. Okay, a very niche knowledge from different fields. It's not just you want to work in algebraic number theory, just know about algebraic number theory, or you want to work in differential geometry, you just know about differential geometry. This is not true anymore. Yeah, we are not in the old days when the field is not mature yet. Now every field is very mature already. So now we want to find idea from different fields. So that's why we have some conjecture, for example, the Lang conjecture, or the homological mirror symmetry. These are the topics, these are the statements that try to relate different fields together. For example, this Gaga theorem is trying to relate different fields together. Okay, so how about we play an introduction game? So everyone, you need to when you introduce, you stand up, say where you came from, where you like to, what you like to eat, what's your favorite sport. Anything else you need to know about your group mate? Okay, never mind. We start like this first. So I introduce myself first. So I'm Seng. I'm from Sarawak, Malaysia. Do you know Sarawak? Yeah. I'm from Sarawak, Malaysia. I like to eat, what do I like to eat? I like to eat sweet and sour stuff. Yeah. I want to say sweet and sour pork, but I think some of you are not halal here. Right? Halal, I mean. Okay, but never mind. And then what I want to play, badminton. Yeah. Okay, so let's start from where? Let's start from here, from Dingson. You stand now and then introduce yourself. Oh, by the way, we need a very important information, right? Whether you have 2209, 2309, right? Okay, yeah.
I am Jingxing. I'm from 2304 and I'm a member for the Chinese camping. Let's go.
Where are you from? Where are you from?
I'm from Malacca.
Malacca.
Hello, my name is Li Hao Tian. I am from 2309. My favorite food is I don't put much emphasis on food. I eat whatever I can eat. Guacamole, I like it very much. And I am from Klang, Selangor.
Greetings everyone. I am Larry and I'm from Sabah. That is like the other islands. And I guess that my favorite food is something like fried food stuff like fried chicken and stuff. And for my
Not healthy, eh? Kidding.
And for my sports, I don't really do much sport unfortunately, but I guess I can play the badminton and I can swim like that. Okay, thank you.
Hi everyone, my name is Jack. I'm from 2302 and I'm from Negeri Sembilan. I like to eat French fries and I like to play badminton or basketball.
Good afternoon, everyone. My name is Gong Shi and I'm from 2209. And I like to eat Japanese food, I guess, and I would also like to play badminton as well if I'm free. And I'm from Sarawak, Malaysia, same as Kishan. And as you know, I'm the advisee or FFE student under him. So you can ask me anything about algebra or anything. Yeah. Thank you.
Good afternoon, everyone. I'm Sonny. I'm a 2309 student. I come from Henan province. I like to eat meat and usually I will play soccer.
Maybe part to Justin first. Oh, Faisal. Yeah.
Hello, my name is Muhammad Faiz bin Fazal Rahman. I am a master's student and I'm from Johor. I like to eat nasi lemak. Okay.
Hi, I'm Jun Hong. I'm a master student here and I'm from Selangor and I enjoy eating fried egg and I enjoy playing basketball.
Hi, I'm Justin. I wish I'm not a master for this particular course. I don't have any particular favorite foods, and as over the student, I believe my favorite sport is badminton. And I'm from Negeri Sembilan, Malaysia.
I'm Tohan Wei. I am 2304 batch and I'm from Projective. I don't have a favorite food or favorite sport.
Empty set.
Hello, my name is Ihe. I'm 2309. I come from Selangor and my favorite food is fried food.
Fried food also.
And I know favorite sport.
My name is Josiah. Google Dion. I'm from Penang. My favorite is fried chicken.
A lot of fried food lover.
I'm Ong Ziqian.
from 2209 in Selangor, and I often eat carbohydrate food a lot. And I think I sometimes play badminton, and I'm always thinking slow.
I'm Lydia. I like to eat omega egg.
Oh, you are the only girl here. Wow. Very precious. Very precious, huh?
I also like to eat sweet food. I like to eat.
I'm Adrian and I'm from Plank. I didn't know behind here was from Plank so until now. And I like food that tastes good. As long as it's good, it's not disgusting. And I don't do sport nowadays and I'm from 2309.
I'm also from the Grace of Japan. There's nothing good to eat here.
Okay, I'm Yao Yichen, and you can call me Eric, and I'm 2309. I'm from Zhejiang province in China. And for food, I like sweet food, very like. If you look at my WeChat, you can see that I post cakes or ice cream, I think, several times a week. As I usually said, I cannot live without sweet food, just like Western countries cannot live without Jerusalem, right? And for sports, I don't like any sports.
So hello, my name is Zhou Qingping. Everyone wants to know my English name is Tommy. I'm from 2309. I'm from Nanjing, China. My favorite food is perhaps pasta, and I play badminton. That's all.
Good afternoon, I'm Young Eugene from Kuala Lumpur, Malaysia, 309 also. And for my favorite food and sport, seriously, I don't have quite a favorite one for food and sport. But if you think the food is tasty or you think the sport is good to play, then that's my favorite one. Thank you.
Hello, I'm Joel. I'm from Sabah and I'm doing my master now. I don't have a particular favorite food, but I drink a lot of milk tea. And for sport, I'm currently doing some powerlifting and also badminton. Okay, thank you. So luckily some of you haven't do introduction and they are auditing this course here. Hopefully they will stay longer as they like. So yeah, about these another negative one that I haven't mentioned just now, right? So after you learn about these people, I try to talk to them. Okay, try to look for the masters and then talk about their interests, and then try the master look for the undergrad. Okay, and then why there's another reason why I put there's a 2209 and 2304 in each group because they did project with me before. Okay, for at least one class, at least one class. 2304 did two projects with me before, so they know what I expect for the project. Okay, so try to check with them. Yeah, check with them what I need. Actually, I specify here, but sometimes right, things happens. So I actually check their draft and then I communicate with them during their project. But this time, I think I won't check draft because I don't have time. So I'll make sure you guys have a good collaboration between you. I will just have meeting with all of you. Okay. And right, so advisor, I put a negative one here. Why I put negative one? If you use it well, then it's good. If you use it well, then maybe it's a disadvantage. Who knows? Okay, so this advisor I put here, right, is optional. You can look for this guy. Where is Ryan Ang? Where's Ryan Ang? So this is our PhD students. Wen Chuan, yeah, Wen Chuan took my general topology before, so he also know what I want for project. And he did quite well in the project. And actually, I put the sample on. You can refer to that sample. Eric Fong, Eric Fong, yeah. Hello, Eric. Yeah, Eric is doing what are you doing? Geometry. Yeah, differential geometry. So if you have a project related to geometry, maybe you can ask him for help a bit. Can or not? Free. If you can help, then help. If you're not, never mind. Right. So last one is Chi Wei, last but not least. Yeah, Chi Wei is an expert in algebraic geometry. So you definitely want to look for him. Okay, so he's a master. So these people are master, except Ryan. So Chi Wei is doing algebraic geometry with who? Again, Munir. Yeah, Munir. Okay, so maybe they can give some ideas based on what they read, or maybe you have some confusion that they confused before, so they can solve it for you. Okay, yeah. Okay, is it clear? Everyone clear? Know what you need to do? Okay, by tomorrow, I want to get 4 lists here. So basically, you guys are split into 4 groups. There are 20 persons here. Okay, so I'll get 4 lists here. For those who cannot find group, right, I will just randomly assign you. Okay, and then I'll start Teams group chat maybe. Maybe this Teams group chat is only involving the leaders and the master. Okay, so where they are good leaders. Oh yeah, right. So I'm going to explain about this natural number 0 here. So this 0 可有可无. That's why it's 0. It can be just an identity. So why is it an identity here, right? So this leader here, basically what you need to do is you need to discuss among 5 of you. Okay, who is the leader? So what does this leader do? This leader need to call for meeting. Okay, check weekly progress. Your friend, did you read something or not? And then make meeting with me and then report with me. Okay, lead the discussion. Okay, because I'm not sure whether the master willing to do or not. If not, you can just ask 5 of you and then vote who want to be the leader. It's fine. Okay, it can be the master itself also can. But I just put an option that it could be undergrad also. Okay, depend on how 5 of you discuss, how 5 of you interact with each other. Okay or not? Okay, and then I will add leaders and the master student into a group chat. Okay, then anything need to report or anything I want to update, I will update through the leaders. Okay, so in this class, there's no class rep. Why there's no class rep here? Because I think all of you are mature enough already. I'll put all the announcements inside the Moodle. Okay, no need to ask people to do a certain passing message. Okay, and then anything you want to ask me about, right? Actually, I set up the forum here. You can ask here. Okay, so we try to learn freely. There's no judging here. Judging is not very good. Okay, judging is not very good. Not very healthy also. Unless it's a constructive judging. Okay, so if you want to discuss, just discuss here. Your discussion. If you want to ask me questions, just ask me here. And then we can add it into the lecture now. Who knows? Okay, because I guess part of the interesting part of my lecture is I'm quite flexible. Okay, I can merge into the way you like, move into the way you like, and also the way I like. Okay, so I think these 2 things, when they combine together, they will form a very fun chemistry here. Okay, yeah. Any announcement I just made here, so please always look at Moodles. I think Moodles will send email to you. Okay, if not wrong. Right. Okay, so we won't have class rep. I will keep close contact with the leaders and master students. So master students will be either the main leader or the vice leader like that. Okay, so definitely I want to train a master to be, I would say, responsible for teams. Okay, yeah, so in future you need to work with people, right? If you need to work in a group, this is very important also. And then for the undergrad, this will train your FYP projects. Okay, you will learn to write a proper report. And then presentation. Our presentation is about 15 minutes. It's about the same length with a FYP presentation, about 20 minutes. It's about the same length. Okay, so mind you a bit, maybe you need to read a lot. Although you write 5 to 10 page stuff, right? You have to read a lot actually. Okay, not just read 5 pages, write 5 pages. It's not like that. Okay, you need to read a lot and then summarize it. What are the important stuff? What are the necessary stuff to include? Okay, does it make sense or not? Okay, I mean, along the way, you will know what happens, especially when you work with these 2209 and 2304, they will know it. You will know it. They will tell you what happened in my project. Okay? Okay. Any question? Any question or not? See, I haven't, if I finish briefing everything. Yeah, actually, I put out a map like this. I draw a map like this. So your group should be something like this. You get a master, and then you get this. And then this four guy need to be split.
Wow.
Huh?
Wow.
We need to balance. We need a balance. Okay. So masters, please be mindful. So master will give me the list of 4 of the master. Where's the 4 master? Again, raise out your hand. 1, 2, 3, 4. Yeah. Okay. By tomorrow, end of tomorrow lecture. Okay. Or before that, you should give me a list. If you think that, oh, I think there's one guy here not around, still not around. So maybe one of your teammates is missing. So let's see who can grab the last one. Okay. Yeah. Okay, so try to take advantage of resting and then maybe after the lecture, try to contact these people here. Yeah, talk to them. Okay. Did I miss out anything else? Anything you want to know about this class that I haven't tell you? Huh? Anything that you want to know about this class that I didn't tell you? Clear about assessment, report, presentation. Okay, before we finish, I mean not finish, take a break. Yeah, so this one maybe talk a bit later. Talk about topic first. Okay. So if it is based on Safari's book, these are the topics that we want to focus on. First is Affine and projective varieties. I think varieties has mistake here. And singularity and blowout, devices and Riemann-Roch theorem, and intersection theory. And special topics are on you. So the previous 4 will be presented by me. Okay. And then, where is it? Yeah, sorry. Okay. Okay, so this first 4 topics will be covered by me. And then actually these are very hot topics in the frontier of research also. Okay, singularity and blowout, devices, and then intersection theory. Yeah, devices form a group. Yeah, they form a group. Okay. Yeah, basically these are also my motivation to look at algebraic geometry. Because I did take algebraic geometry, but it's a functorial algebraic geometry. So by that time, right, I don't have much knowledge on these curve intersection stuff. So actually, this is also a chance for me to look at these things again, study back these things. So actually, we are studying together. And so I also don't know anything about algebraic geometry. I know nothing about algebraic geometry. Okay, because maybe some who know something about algebraic geometry are not willing to start this course, but I'll take the job. Okay. Yeah. Okay, hopefully you can be more tolerant on me. Okay, more tolerant on me. Okay. But we don't strictly follow this lah. It depends how I goes. For example, like we won't start straight on affine and projective varieties. These are just some aim we want to reach. But to reach this aim, right, sometimes we need some background. Okay, I will pick some important background that I think is necessary. Instead, we'll start with geometry and algebra. Instead of algebraic geometry, we start with geometry and algebra. So we need to do some basic geometry to get intuition, on affine space and projective space. Okay, using axiomatic way, using axioms. And then we'll do a bit of algebra. So what kind of algebra we do? I will do commutative algebra a little bit. Okay, so that later on we can use it. Okay, when we reach the Hilbert bound. Okay, no? Okay, so we'll split up. We'll do geometry first, pure geometry, and then we do pure algebra, and then only then we combine. And then actually this process, I think I suspect I will take about 4 to 5 weeks. It's quite a big topic here. Okay, how to announce that result. And then only then we will go into singularity device and intersection theory, so on. Okay. See how it goes. I'm not sure whether we can finish all these topics or not. If we cannot, then we just leave it like that. We just test on what we learn. That's all. Can or not? Can understand? Understand? Okay, depend how we go, how far we go, where we go. We just test on those topics. Okay, we are not very restricted. Okay? Can or not? Does it make sense? Make sense? Okay. Any more questions? If no more question, let's take a 10-minute break until 1:03, and then we'll come back for lecture.
哦，等一下我再提一嘴。OK， 你刚才又不要讲，一直问有没有东西漏，又不要讲。
我想
哎，很烦的。这个学期不要太烦我，因为我
为什么
啊？
为什么？
因为我准备很多东西。
OK，
呀，最好听一下我的话，要不然的话我会发脾气。你玩我的儿子。
然后我还没见过你发火
啊？
还没见过你，
还没见我发火，我可能会比 TLP 还凶。
没办法发
啊？有没有发火过？
没有发，
没有，
只是他不耐烦会看得出。
对
啊，不耐烦说一句，他就这样。
哎。哦，这个那天那个 ，OK OK， 哦 OK OK。哎 ，actually 这个我有重新写过一次，在我的新的 note 里，要不要再读一下？我刚刚放罢了。我今天想一下，还是放上去了。
还是有进来
怕你们会卡住。
现在的版本是你最新更的吗？
啊，对，还是一样。它会有日期那边，你看。没有，它的 sub case 我解释的比较一起解释，这个是分到很上来看。对啊，但是你分到很上做到完，就是可能就是我讲的那些东西。你会乱？
像刚刚说过这样。
对，没有错 ，exactly。它其实东西是在重复的。你把一个东西做好了过后，其他的等于其实是类似前面的等于啊。对对对，我有注意到，我注意到，他们注意到。等我教完过后，我们再决定怎么样。应该会。有没有教到？没有教到。你做了没？
完全看了。
没有，
我也没看。
我有注意到，我们有慢了一点点。
吃完饭去吃，上完课去吃。你吃饭了吗？
还没。哎，其实吃一点点。
那就上完课去吃吧。
可以。
上完课然后直接来你课。
对，
中间点到中间。
我们有没有早上上？
他们那些 service， 我们要跑进到 group 里的。OK。哎，所以
对，
找什么？
刚那个你在找个 team 啊，就是
要是 team。
这样说明一个 25 到 27 group。
我俩一直分那个 team。
OK，
哎，那个什么，哪几个人是2.0？哪几个人是2.0？对，哪几个是8.4？
你可以聊，
我就不懂。继续找。
我也拿纸给你看呢。
你是哪个？哇，我是209。我是为了去找。
你是那里人？我觉得我这边来的时候，
你要我那个话，叫我
要证明有
要进步的精神，没有人要来。
你们几个人？
我们这边就是234了。
234。我不想吃，我不想吃。
这个是算了。
template 我们那 progressive 会听，但是我们自己去
我想一想，但是就是你觉得要记录什么？方便来的，我还没有很 specify 出来了，但是我觉得也没有什么 template，就是大概应该就是日期做的。但是我会大概在想清楚。位置先，反正 template 很重要的，重要的就是。
哎，我这边组好。
那你的 master 发给我。
你今天给我的slide吗？nonsense。
我平时会这样来。对。来，情况这样。听不起来的东西。监控是不是处理保险相关的？一个是你看你的不能问，
为什么呢？
丁生，你是属于2209啊？因为你的 ID 是209。我们是看 ID 啊，不是看 batch。We look at ID for these 2309 to 2209 not batch.
刚才我不讲话。
Okay, let's start. For the masters, right, you can give me a list of your group first if you haven't really split your roles yet. So you haven't decided who do who first, but you can send me a list satisfying this condition, you just send me. And then you can secure your people first, and then only then you go into this workload. Like you still have time to decide. I think at least 2 weeks before you meet with me. So you can decide later. But at least you need to send me people that satisfy this group. If you don't satisfy this condition here, I'll reject your group. That's all, very easy. And then you go and find again. Okay, yeah. So this, by the way, this is following the uni ID, not batch, because there's some circumstances here. People will move to different batch, but just following the uni ID. Okay. Okay. Right. So before we start, my class is about like the lectorial class. So sometimes we'll break into discussion. Sometimes we will break into brainstorming, something like that. Okay. It's not meaning it's just not me speaking non-stop here all the time. And you can ask me, stop me at any time. And how we organize our knowledge here. First is we'll use motivation, question, observation, maybe recording, and maybe some history to bring up the subject. And then definitely very important part is definitions. Okay, we'll state definition very clear, axiom that we use. And then followed by examples because otherwise your definition is empty, no need to study. Okay, or sometimes maybe I will skip examples also if it's relatively easy to see. But if you think that it's very important, you can still ask me to provide. Obviously, we will have homework exercises, something that's tedious to check in class. We won't do it together. Especially this is for advanced course. You should know how to do it yourself, little things. In case you found out that the thing is not little and then you stuck, you still can look for me after the class. And then next part is theorems, propositions, lemma, corollary. So these are the important consequences from the definition. And we should prove them. Okay, we should prove them. Every theorem or statement, we have to prove it. We cannot just say it. In particular, in this class or in every of my class, right, I try to make it self-contained. Okay, self-contained meaning I don't want to say something, this is granted, this is granted, take for granted. Nothing in this world is take for granted, I want to tell you. Okay, so there's a saying said there's no free lunch in this world. There's no free lunch in this world. Okay, nothing can be taken for granted. Okay, if can, I'll try to be self-contained always. Even if I don't prove in class, I'll provide you. Or I ask you to refer somewhere else. 6 is about notation. 6, maybe you might think that it's not very important, it's just notation terminology. But this is most place where people get stuck. Because when people change notation, change terminology, you will see that, hey, where is this come from? Okay, so this part actually is important. Whenever I want to define new things, right, give you new terminology, right, because I'm going to use it. Okay, so you need to be aware. Okay, when I do this remark, because I'm going to use it. And then the last one is extra stuff that we think about the ideas. Okay, maybe some comments or add-on. Maybe this add-on could come from you actually. Maybe you have some extra idea whether this works or not. Whether does this fit to the other things. If I have anything, I can add to it as well. Okay. Yeah, basically these are the 7 colors, the rainbow you will see in this class. Okay. Why I put them as a rainbow? Because when you do revision or you want to look for something, right? If you want to just look for example, you just go to the green part. If you want to just look for definition, you just go to the blue, white part. Okay, that's why we put different color here.
Okay, so imagine if you read all the words matched together, it's very hard to find. So that's why we put a different color. Okay. Yeah. So in this case, let's not wait anymore. Let's start. So now we're gonna do geometry first. Okay, do plane geometry. No, plane geometry. Okay, just do geometry. What we're gonna do is axiomatic geometry here. We don't quite do Euclidean geometry, but we will do affine geometry and projective geometry to give you some intuition on spaces. Okay, so let's start with affine and projective space. Okay, let's start with space. And so these two are the most basic space you need to know in this class here. So let's define it. So first, let K be a field. Then we're going to define what is called affine n space, or affine space sometimes. Okay. So what is affine n space here? So the notation we're going to use is like a bolt A with a power n and then subscript K, field. Okay, so affine n space over the field K. Okay, is what? Is a set. Okay, it's a set of what? Basically, this is not far different or exactly the same as you take n tuples of k numbers here. So these are all the n tuples of elements from k. Okay, so if you write it as a set form, okay, so if you write down the n tuples here, this is like bracket, round bracket of a1 up to an, okay, where you pick these ai from for OI. Let's not write down the full guys for OI. Okay, maybe let's write it down. So in this I from 1 to n. And all the elements here, what are the elements here called? Okay, so this should match your intuition. We should call it just a point. And they are just a point. Just call them a point. Okay, for example, a point in Rn, a point in R2, R3, okay, it's a point. And what are these AI codes? What do you think? Actually, these are the coordinate, the I coordinate, and the I coordinate of P. Okay, so this matches your Rn intuition, right? Actually, this is just replacing R with different field. Okay. Yeah. So I want to put a remark here. So sometimes if the field is understandable, we know that what field we are using, we will just ignore it. And we refer this field as ground field. So this K is the ground field that we use, and the number we're using. And we will simply write just both A to the power n. Okay, if we already know what field we are using. Okay, otherwise you need to always keep asking yourself what is the field we are using. Okay, and why is it affine? Why is it we are using affine here? Typically, this affine means that we don't really care where we put our origin. Okay, so this affine suggests that we don't always take 0, 0 as our origin. Or the additive inverse, additive identity. Okay, the additive identity, we don't take it as our origin often. Okay, if you learn more about the affine transformation, then you will know why we think like that. Okay. Yeah, we don't always care about the origin. Where's the origin? We can put origin in different places. Okay, other than the additive identity. Okay, so let's recall some familiar examples. So what are the familiar examples? Let's fix some n and k, okay? So what n and k we can fix here? Maybe you can look at the affine line. Affine line. So if we set n equals to 1, and then k is just random k, is just k. Is this a number system? Okay. In particular, if you set it as r, then it's just the number line, real number line. Okay. Yeah. So maybe you will think that why we need another name, because you can think of it, we don't care about the origin in algebraic geometry. Okay. Second, you can get an ordinary plane. Okay. Ordinary plane. If you put n equals to 2, you will just get k squared. Okay. Or in the linear algebra, what you will get is you can learn about this finite dimensional real vector space Rn. So what is Rn here? So we also can get real vector space. Just set a random n and R if you look at a real vector space. Okay. So what I want to say here is the object you study across analysis, linear algebra, all of them can put into algebraic geometry. Not all of them, but most of them. Okay. Clear? Affine n space. Okay. Okay. So next, we're going to define projective n space. Okay. So what's a projective n space here? So we use P, okay, for P projective. So similarly, have a power n and a subscript k here. Okay, P and k. Again, over the field. So we need to decide what number we can pick from number system. Is the set of equivalence. Okay, it's a set of equivalence relation. So what do we equivalence out here? So it's a set of equivalent class where we take an plus 1 over k similarly. Okay, but we take away the origin. How do we denote the origin here? So we take away the origin such that we put an equivalence on it. I'll tell you what's the equivalence. So this is a set of equivalent classes. Okay, in the affine n plus 1 space, okay, throw away the origin. Okay, under the equivalence. So what's the equivalence here? So we will say that A0, A1 up to AN is the same as B0, B1 up to Bn if there exists a non-zero scalar, okay, in your K, such that what? All these AIs are multiple of each other. Okay, let's spend some time look at this definition first. So later I'll complete it. What is this guy? So let's then spend some time looking at this definition here. So what is projective n space? You look at n plus 1 affine space. Okay, you throw away the origin, and then you impose a equivalence relation. So what's the equivalence relation here? What does it mean by there exists an R such that AI equals to RBI? What does this mean here? When is this true? When they stay on the same line. Okay, when they stay on the same line. As long as there exists an R, okay, then you can identify them together. Okay, actually you identify the line. There's another details I want to see here. I start with my A with 0, and then I end with n. Okay, so this actually n plus 1 tuples here. Okay, so it is a point in n plus 1. But why I choose this? What do you think? Why do you think? To match the n with the Pn. Okay, to match the if I obviously I can write A1 up to AN plus 1, right? Whatever. But then that will be matching with AN plus 1. Yeah. Does it make sense? Okay, so
There's one thing you need to remember here is a projective n space, right? You go to a one-dimensional, use dimensional illegally first. One-dimensional more tuples, okay, one more tuples, then you do the equivalence. Okay, so basically, what is this? So since this is an equivalence relation, right? So how does this elements look like? You can form an equivalent classes. Okay, so you can form equivalent classes. So how do you write equivalent classes? Maybe we'll put a square bracket like this. So it is represented by a point, right? Okay, you just pick equivalent class. Sometimes we will write this equivalent class with a round bracket. Also A0, A1, up to AN, but in between we put a colon. This is called semicolon or colon. Colon, right? Semicolon is like this. Okay, so this is colon. Okay, so we will write it as colon instead of comma. Okay, this comma is a point. Okay, we will write this a colon here. Okay, so this colon here is no longer a point in AN plus 1, but it's a subset of n plus 1. Correct or not? Because it's the equivalent classes that represent a set. Okay, it's a subset. Okay, so basically we if once you have an equivalence relation, right? Basically, equivalence relation will help you partition the set. It will help you partition the set, and then this is one of the representative. And also, this representative will represent the whole partition you have. This is a standard language we learn in discrete math, right? As long as we have the equivalence relation, equivalent relation will partition the set. You want to ask something? No, okay. Okay. So where do we get this equivalence relation? This is the equivalent relation from the tilde we defined just now. Okay. Okay. Or there's another way to look at it. This is one way to look at it from AN plus 1. Or if you just want to look at it in P. Look at it as a power set. Can we look at it as a power set or not? Yeah, because it's a subset, right? So we can look at it as a power set. Power set of A n plus 1 k. Take away the origin. Okay, such that what? Such that can you write this nicer? Let me think. Such that this set here will contain all the multiple of A0, A1, AN. Okay, for all R not equal to 0. Okay, although we said that this is a line, actually this is a punctured line, right or not? Because we don't taking the origin. Actually, it's a punctured line. Why we want to do a punctured line? Anyone has idea? Why we throw away the origin? I mean, why we throw away the? So I mean, if you take R with 0, right, then this 0 will live in every partition. Okay, so we just throw it away. Yeah. Oh yeah, thank you. So here is just point, right? So here is point. Yeah, thank you. Okay. Yeah. Okay. So one thing to check is I didn't check for you, so you try and check yourself. So try and check that this tilde here is actually an equivalence relation. Okay, so this is a very good starting exercise that you could do at home. Okay, check that it's really a equivalence relation, meaning it satisfies what? Reflexivity, symmetry, utility, and transitivity. Okay, so also notation. Sometimes we'll just write Pn. okay, instead of P and K. Okay. Where is it? So the latex will call you, right?
Yes.
Yeah, so that's why you know. All right. Yeah, speaking about this, because they always help me to do the typeset, so they're bothered by latex a lot, so they catch these bracket thingy. And another thing is, maybe some of you want to help typeset this lecture also. Okay, if you want to do this job, right, I can contact. Or you want to contact Eric. Yeah, I think he's quite busy. I mean, if you cannot afford it, right, maybe you just keep one of the job. Yeah, because he's trying to do general topology. So if you can help him, willing to help, you can help him.
Basically, I need a person to help me draw the graphs and to do some exercise.
Yes, because I did a lot of exercise. Okay, yeah. So if you can help him, because when you help him, right, you also learn at the same time. Okay, you force yourself to do the exercise. Okay, no? Okay, continue. Let's continue. Let's do a remark here. Let's study this space a little bit more. We will actually spend more time in projective geometry. Okay, so not that. We choose the index for an plus 1, okay, starting from 0. Okay. So for example, when we discussing P and K, whenever n not equal is non-zero, okay, what can we do is we can always pick a nicer representative here. We always can pick the representative, or we can take the representative 1, comma 1, no, semicolon, no, colon, A1 over A0, and then A2 over A0, and so on. Okay. Okay. It is clear that if you multiply by A0, right, you should get the A0, A1, A2, and the AN point. Okay, so this is a nicer representation here. So what can we do with this nicer representative here? So in this case, actually, we build a 1-to-1 correspondent, okay, from the set that contains A0, A1 to AN, where A0 is not 0. Okay, by the way, this is a subset of, is this a subset? Let me think. This is a point. Okay, so this is a point in Pn. Okay, so I changed this notation to here already. And with what? Okay, let's write down here first, and then we'll guess from here. So this set here, right, let's call it U0. It's U0. Oh, right. So we're just not looking at one point here. We look at the multiple point here. Let me see. Yeah, it's just a point. Okay. Anyway, so if you look at a particular point U0 that we had just now, so these are the UI. These are the UI actually. Okay, so if you just look at the U01, so when U0 is not 0, sorry, A0 is not 0, what we can do is we do a little UI map. So what's this little UI map? Instead of remembering all the number, right? So I just take A1 over A0. Okay, so meaning I pick up a representative. Okay. I pick up a representative here. But where does this point live in? This is just how many tuples here? N tuples. Okay, so these are the guy living in Affine N space. Okay, so there's actually you can check that there's a 1-to-1 correspondent. There's a one-to-one correspondence here. Okay, sometimes we call these okay, so this is part where A0 is not 0, right? How about the set when A0 is 0? We'll call this set as a point of infinity. One of the point of infinity. We'll call this where A00 is then refer as a refer 2 as a point of infinity. Or point at infinity actually. Infinity in P. Okay, so you can see that this is not restricted to U0, right? You can do it for different AI. Okay, it's the same. Okay, but this has a very interesting consequence. So basically, we actually can split Pn into An union a smaller projective space. Okay. Does this make sense? Does this make sense? Can you see it from the map that we made just now? So one part, you can send it to ANK. The leftover part is again a projective space. But you already fix your A0 to be 0. Okay, so they are like left with n of them. But this n projective space, I mean, this n affine space will give you a n-1 projective space. Correct? No? Got question? Hey, got question? Please raise it up, because I don't want to like keep asking you. Hey, 吃饱了吗？吃饱了吗？要不要吃现在？ Okay, so now you be mature enough. Directly ask me, what about this? What about that? What about this? Okay, I don't want to like sit beside you, keep asking you to eat, please eat. Okay, yeah. Okay, so if you can do this right, you can imagine that you should be able to do it inductively. Okay, you can apply this argument inductively, such that you can get all the way up to what? A1 union P0. Okay. Yes. Yes.
Space is a space of punctured lines, and AN is a space of n dimension.
Wait, let me think. Oh, yeah, right. Okay. Wait, so you are trying to say here we should get rid of 0? We get rid of 0. Wait, let me think. No, I continue first. You continue first. Which one?
So can you actually use the set, say the set union on two totally different things like this?
Oh, I get what you mean. Wait, let me think. So let's see how.
What category are we?
Wait, let me think carefully again. Okay, so okay. Let me rephrase a bit from my understanding. So well, I mean, okay, right. I think you get what. Okay, I think I get what you mean. So you say that okay. So actually, these two. Okay, if I put this right, maybe you will think as a set equality, right? Okay, you will think it's a set equality such that the point on the left should be on the right. But as we can see that Pn plus 1 and An really is a different set. Yeah, I mean their elements are coming from different set. Yeah, in particular, this Pn plus 1 is a set of equivalent class of point, but An is a set of point, right? Okay, so this is the problem here. So how to solve this problem? So what am I trying to say? Yeah. Bijection. Just bijection. So I cannot put equal here. Isomorphism. As what kind of isomorphism? Yeah, alright, so just bijection.
Yeah, for me as variety, but we haven't defined variety.
Oh, you mean the map of varieties? Okay. Okay. So okay. Sure. Okay. Sure. That part I'm not fully confirmed yet because I haven't really looked very close into the map of varieties. But okay. So let's leave it as bijection. Yeah, let's leave it as bijection. Maybe I think it's right to phrase it as a map of varieties, but I cannot recall the actual formal language for you now. Huh? Homeomorphism. That one not sure. There's no. I haven't tell you the continuities. I mean, okay. Maybe you can solve homotopy also. I don't know. But anyway, yeah. Okay. I think there's one more point. Right? I think you need to throw away. Okay, you don't need to throw away. Actually. Okay, never mind. There could be a 0 point there. Okay. Right. Okay. So one thing I want to you think about this proposition is if you look at what is P1. Okay, let's look at P1 here. Proof is exercise. Proof just leave for exercise because actually I tell you the step already. So what is P1 here? Let's look at P1. So P1 is A1 union P0. Okay, so what is P1 here? So how do we define P1 actually? Okay, let's look at the original definition first. So it's actually A2, throw away the origin, and then divided by some equivalence. Okay, so let's draw this. So A2 with some field, right? Let's look at real numbers for easy life. So what do? You get rid of the origin. Okay, and then you regard a line as a point. Regard a line as a point. Okay, something like that. Okay, but how do you think of this as an A1 union sum P0? What is P0 actually? What's P0? P0. So let's check out what is P0. Let's use the definition. So P0 is what? A1. Take away. So A1 like this. Take away a 0 point. And then take the equivalence. What is in there? Some 1 point, right? Just a point. Because it's just a one line. Okay. So basically it says that you can split your P1 as a real line plus a point. Can you see a line and a point in this picture? Semicircle. Okay, so because why semicircle? Why not full circle? Correct. So these two antipolar points represent the same point. Okay, so you just take half of them is enough. Okay, and then and an infinity point. Where's the infinity point actually? This line. This line represents infinity. Yeah. Okay. So wait. So this red line represents what number? 0, right? Because the gradient is 0. Okay. Let's put M1. Okay. Right. And then the vertical one is infinity. So this M is okay. Okay. Any question? Okay, let's continue. If you have question after the class or after I say, you can just feel free to message me. I might say wrong things, mind you. So I mean, we can check together. Want to continue or? Okay. Yeah, feel free to
stop me at any time. I might say wrong thing sometimes, so feel free to point out. Okay, so next proposition is I think what we have discussed before. Actually, what is a projective n space? This is actually all lines in an K. So this is n plus 1 affine space passing through the origin. I think the equal here again not very precise, is it? Because I didn't throw away the origin. But let's say if I all the line without the origin, then it works. Okay, if you include the origin, maybe you just have bijection. Why? Maybe a very straightforward thing you need to know in this statement here is what is the line. Okay, what's the line in what does a line in affine space mean? Okay, so what's the line? Okay, what's the line? How do you describe a line? Okay, I think we taught a lot in this calculus 2. So how to describe a line? You just give me a point and a direction vector. Okay, so it's uniquely determined by a vector. Vector, direction vector, non-zero one. Non-zero vector. Okay. So then what's the line? It's really just a multiple of this direction vector. Okay. Actually, you also feel very familiar, right, with this writing here. Don't you find your null space in your linear algebra look like this? Multiple of some vectors. Did you see or not? When you solve your linear algebra question, when you solve null space, you have an idea? You can recall some free variable times some vector. Okay, almost when you get a non-trivial, I mean, every time you got a non-trivial solution, right, you should start with a free variable and then give you a line. If you have two variables, it gives you a plane. Okay, yeah. So your non-trivial solution to your linear system always. Okay. Okay, and then I mean, I don't want to write more because if you look at this, this is exactly the equivalence relation we impose in our projective space. Okay. So now, okay. Yes, question.
If state is using circular parentheses with semicolons instead of
with colon. With colon. Instead of comma. Yes. Or if you like, you want to use this also can. If you want to use the algebra notation also can. But their geometer language is this, I guess. I'm fine because I'm algebraic. So if you use algebra notation, also fine. But I think geometer they use this. If you want to use equivalent class notation, I'm also happy. As long as you know what you're using. You don't combine all these notation together. Don't combine all of them, then that's fine. Yes. Yeah.
square bracket with colon.
Oh, I don't know. You mean like this? Like this? Square bracket. Oh, without this? I don't know. Which book you using there? Ashon. Differential geometry. Okay, I didn't know. I actually don't. I mean, work a lot with this stuff, but for now, I think for most of the reference I see is like this. Yeah. I mean, Hashon. Yeah, Hashon is another classical book that we always refer to. If you want to know what is the portion we did in Hashon is chapter 1. We aim to finish chapter 1. Okay, we aim to finish chapter 1. Okay, in Hashon. Yeah, that's the only thing we can do because chapter 2 is scheme. Okay, we don't do scheme in this class. Okay,
We don't do scheme. Okay. Yeah, we aim to after this course, hopefully you can understand Harsham chapter 1 very well. This is the goal. Okay, this is the goal. Okay. All right. So let's go a bit into geometry. Hopefully we can catch up some progress. So let's do geometry in affine and projective plane. So we'll do up to 2-dimensional first. Let's see what picture we can get from this two objects. Okay. So first of all, let's define a line. Again, this is a line in A2. Okay. Basically, what's this line here? So let's be quick. It's the set L defined by, obviously you need to pick the point from the plane. Okay, but they have to satisfy what equation here? Y equals to mx plus c. Okay, so in this case, in general case, you have ax plus by plus c equals to 0. Okay, for some a, b, c inside your k. Let's say you are taking for some. Okay, if your point have number system in K. And then we're going to define what's the parallel means. Okay, so two lines L and M are parallel, which we denoted by L double line, okay, without touching each other. M, okay, very symbolic. If, what do you think? Either they are equal, they are the same line, or what? Or they don't intersect. In other words, they don't have point in common. Okay, so this is what parallel means. Okay, there's no common point. That's all. And then this will draw you the parallel line. So if you are in parallel with someone else, maybe you don't have common interest. So you cannot get to know that person. Parallel, there's no common interest. Okay, so this is about parallel. Next, collinear. So what is collinear? So collinear is about 3 points. Actually, more points. Okay, more points we can talk about it. So n points is said to be collinear if there's a line joining them. Or in other words, there's a line containing them. Okay, so you can see that we just use set language here. We just use a set language. So P1 up to Pn is in. Yeah. Okay. No matter what line you have, because you could imagine you have a different geometry. For example, hyperbolic geometry. Maybe you could have a line like this. Okay. In Euclidean geometry, so let's say this is so in Euclidean geometry, maybe you have a straight line only. Okay. But what we deal with now is a Euclidean geometry. And if you abstract it, it's just an axiomatic geometry. Okay, so this is the idea. Because, okay, by the way, because, wow, they are waiting so fast already, I could still got 4 minutes. Let them wait. Okay, so this class are a bit weird. Okay, how to say weird? The decomposition is weird. Okay, because there's second year, second sem here, and then there's a third year, last sem already. So they have a different background. Okay, they have different background. Please bear with me if I talk with different background people here. Okay, I try to do as far as I can. Okay, for example, if I'm gonna use a general topology knowledge here, I will talk about it. If I'm gonna test you, for sure, I will bring it from the start. If I just trying to do some sharing, I just comment a bit. Okay, if you can get it, you get it. If you cannot get it, never mind. For those that I want you to get it, I will say properly. Okay, yeah. I still got 3 minutes. Okay, let me do some more. So a proposition. So a set consisting
points, 16 point in A2K and line. So we consider two things, line and point together is a set called the affine plane. Okay, so affine plane is a set that containing these two things, satisfying three properties. We finish up. So satisfying three properties here: A1, A2, and A3. Let's draw it up. Let's don't write it. So if you take 2 points, P and Q, distinct point, okay, they are distinct, then there exists a unique line that joining them, meaning containing them. So there's a unique line. Exists, exclamation mark. The other one is if you take a line, okay, with a point P not inside this line here, let's call this line L. Then there exists another line, call it M, such that this M is parallel to L and then contain P. And then the last one is there exists three non-collinear points. Okay, so there exists three non-collinear points. So maybe like this. Yeah. Can I draw like that? Three non-collinear points. And there's these three non-collinear. Okay, so try and go back using the line definition that I showed you. Prove these three axioms here. Yeah, and then maybe a very easy exercise actually. If let's see, we need to go through again next section. But try and go back to it. Okay. All right. See you tomorrow.什么？哪个？哦 ，sorry，there's this three non-collinear。
这几个是可以证明的吗？还是
可以证明？可以证明？
不是 axiom。
我们有 space 啊，我们要证明它符合这些条件。我们可以拿这个做 axiom， 然后只要符合这一套 axiom 的，就是叫一个 affine plane， 也可以这样子做。但是我们现在要证明的是，我们的 A2K 是一个 affine plane。
那我们现在是怎么定义 A2K 的？
就是前面定义啊。
OK，
前面不定义啊，一开始就定义啊，就 double 是吧？
就直接用 double 来定义。
对。然后我已经定义线给你，我已经定义线给你们，定义给了。
这个应该要后面讲。
哪个？
因为这个。你那个 projection 啊，projection